Okay, so let's have a look at routing the tracks which can't go directly on the top surface. So what I'll do is I'll zoom in and I'll start with the two analog to digital analog lines, sorry, ADC lines. And I need to cross all those tracks there to be able to get to those pins over here. So to do that, what I'm going to do is first I'll just move this out of my way, this capacitor. Okay. I need to bring those tracks closer together so I don't have such a big distance to cross. So what I'll do is I'll select this one here and bring it in a lot closer. Now all those I can still get them a little bit tighter. So what I'll do is I'll leave this one here, and I'll start bringing them so they're very close to each other. They're just a 0.25 distance from each other, and that one there. That makes that distance a lot smaller. Now what I want to do is just make sure that those the connections are proper here. Now at the top it doesn't really matter how that goes, but I can just make this one a little bit high as well. Yeah, that's it. Okay, now that line there, I need to bring it closer. That corner I can bring in, and this line I can bring very close. So this gives me opportunity to cross that a lot more gracefully, I guess. I'll bring this closer as well to give us more space. That line there, I'll do the same. I'll just go in, and I might actually create a little, not sure about that distance there. But I can definitely bring this closer again. And that gives us a lot shorter distance to cross. Now that will have to also cross to the other side. So yeah, but I'll leave reset as the last connection. It's not important. Well, it's not a critical track, so it doesn't matter how it goes, how it gets there. Those are more critical, so higher priority. So I need to cross through. So what I'll do is I'll zoom in a little bit. I'll start my track, and let's say from this point, I'll come close to those lines there. Now I'll just left mouse click to position that point. Actually, before I do that, before I do the click, I'll press V on my keyboard, and that gives me the via. So that is, and I can bring that via close to that line there. You can go as close as almost, touching it, but I'll just back it off a little bit. Click there. This is my via, and now the blue track indicates that we are on the other side of the board. So we are now at the back side of the board. I can cross those lines safely. I can come out again, so I'll just press V again and position my via, let's say here. And now we are back on the top. So this is how we can go around it. What I'll do is I'll just I'll continue along along here, and this is ground 5 volts. I'll just come around like this, connect it through, and then I'll decide what to do with this space. I'll probably have to push this out and put capacitor in that space, but that's okay. For now, that's all good. Now let's run the other track. So track, I'll connect to this end. Now if I zoom in, press V, position it right there, go underneath of the board, come out here, press V again, and click, and we are on the top of the board again. So what I'll do is, and what happened there? I'm on the wrong side. Why am I on the wrong side? Let me check. Yeah, I am on the wrong side. Okay, so what I'll do is I'll just finish it here. So hit escape. I know that we need to swap those around a little bit. So what I'll do is I'll just hit escape, make a bit more space here because we need to be on the inside. Move this out, and I can move this via. If I select the via, now to select the via, I have to actually activate the selection on the right hand side there, selection filter, click on via. If I select that via, I can move it. So now I'll move it over here, that's fine. And now I can go back to my track. Make sure that you are on the top layer, and I can connect that from that via. Now I can go, just go like this and connect here. So, yeah, I didn't need to swap it there through the via. So what I'll do is I'll run this. Yeah, I'll leave it as it is for now. I'll leave this as it is. I can adjust it later. So now I want to run this reset into that area here, and I need to cross somehow through all those lines there. So what I'll do is actually I'll modify this one to go like this. I can even get it closer, just to make sure that we've got a short distance to cross. And I'll go from, and I can start from this point, come down here somewhere, press V, place my via, go under the board. I can actually space myself out a little bit there, press V again, place it, and then connect to that pin. So this is not too bad. We've got 3 of those crossings right there. They're not big in size, they're only a few millimeters long. Distance between them, we can either keep them tight or we can spread them out a little bit to make sure that we've got ground plane in between. It's not going to matter in this case. We can leave it as they are. I think that's still okay. Now that reset also has to run here, so I'll leave it out because I will still need to track something else. So that looks okay. The top part is done. I'll save it. And now let's have a look. What can I do about those 2 capacitors? Because that area here is still not resolved. So I'll zoom in. And those capacitors, ground and 5 volt, what I need to do is escape, select capacitor, rotate it. So I've got 5 volt coming to the inside. I'll do the same for this one. And I want this one to be as close as possible to this point here. So I'll just move it here somewhere. And yeah, you don't need the ground plane anywhere there. So I'll just move it here. And I can do direct connection between those 2 points. From here to that. Want to escape. What's happening? I've got a track there. Okay. And it's not going to work. Oh yeah, because we've got 5 volts and we are using track width of 0.5 millimeter, which is too much. So I'll switch that back to 0.25. And now I should be able to connect it. Yes, not an issue there. And ground is automatic connection to the ground will be made. Second capacitor, it has to go close to this pin. So what I'll do is I'll just zoom out. I'll make sure that I've got some space. So yeah, this is moving a little bit sort of awkwardly, I guess. I can keep moving this out. Okay, capacitor, I'll move it in. Now I've got collision there, but that's fine. What I'll do is I'll just make sure that I've got enough space for this capacitor. And there's a ground there as well. So realistically, I need to make still a bit more space here. What I'll do is I'll zoom in. I'll probably move this one out a little bit. And you can see that the track did not adjust. So I'll just, I don't have to shorten or do anything. I'll just go straight from here, come up and connect it this way. Now that little segment there, I can select and delete. This ABC line, I need to straighten that, and I want to really push it further. Okay. Now this is not too bad. I've got enough ground plane there to connect to. I can just select the track and just connect it at 5 volts. We are close. Now you can probably get this one a little bit closer, but it's still very close. It's still pretty close. You don't have to stress too much about it. Now at the moment we're not worrying too much about all those designators. That's a nice area here. So yeah, we are okay in this area. 5 volt again, 5 volt is sort of gives us extra lines there. We don't really want to see at the moment, so I'll just switch that net off, and that makes it clearer to us what else do we need to route. And there's not much. There's only 4 or 5 lines. That's it. Okay, so now let's have a look at the bottom two. And to do the bottom two again, we need to create the shortest possible distance to cross. So what I'm going to do is, and I can, yeah, it doesn't really matter. It's 1, 2. I'm just looking how many connections do I have to do across there. And this is 2 lines there and nothing else, just 2 lines. Okay. So what I'll do is I'll zoom in and I'll start bringing those closer together. Oh, I've just disconnected it for some reason. Well, and I'll change that back to Usenet class. So I'll bring it closer and then connect it through there. Whatever is left over, I can delete. Just select and delete. And that corner, I'll bring it in. You can see that shadow, it tells you what is the minimal track width. Not track width, but spacing. So here we are going to bring that in as well. That track in. Next one, what I'll do is I'll move this first. And now I'll just readjust all those tracks again to make sure that we've got the minimum distance to cross. There's quite a few of them, so so we have to be quite, oops, didn't want to change that. Might have to do some extra adjustments in a minute. Let's just do what we can do. Okay, and that one there as well. So I'll probably create another connection. I'll just go, hold on, this is going here. I just have to think what's the best way to connect. I'll leave this middle area clear, so I'll just come from here somewhere. and connect through to there. Now that gives us a reasonably short distance. It's not too bad, I guess. We're coming on angle. Realistically, we can push all those tracks lower, so we don't have to come on angle. We can just go directly across. It's not going to make a huge difference. But I still have a couple of lines here to connect, so I'll do those because they are going to be a little bit tricky. And so the first one, I'll come down to sort of close to the clock, run along, press V, and I'll need to just cross that bridge somewhere. So if I select this, press V again, cross that track, come out, I can now connect to it. And what do we want? Direct connection, the closer the better, I guess. What I'll do is I'll just leave it here for now. And I'll have to tune those up because I don't like the way that one. I don't like this sort of comes out. Might have to move this one a little bit, that one a little bit. Okay, they're not equal distance, like you can really bring them much closer. Yeah, that is nice, and we can leave that little gap there, or we can just connect it right like this. So that connection there, obviously there is a little issue here. I want to move that truck down, and just thinking how to do it gracefully. Let me just connect it first. If I connect from here to there, that's not a nice connection. I don't like it. I might actually run it out a little bit. And this one, maybe even delete that one, move this one up, move that point there. A little bit better, I guess. A little bit better. Now, next one is this one here. There's a connection going to that pin there. And I can actually go from that pin in between those two. And now I have to cross those two lines there. So what I'll do is I'll actually come here and finish it off. Now I have to make some space. So what I'll do is because the other two lines are coming there, so I'll probably create another connection there, like so, and we come into this pin there. Okay, so I can just follow this along to this point here somewhere, press V, come across, press V, and connect. So we just created that little bridge there. Now those gaps, I don't like them particularly because they're too thin for ground plane to flow in, but again, it's just the whole chip is only 6 millimeters across. Realistically, those gaps are so small, it's not a big deal. If we want to bring everything closer together, we can. I can move this one up. I can move this one up as well. And here, because there'll be some ground plane there, so I can move maybe this segment out a little bit to make sure that it fills. The rest of it is fine. It's don't have to obsess about it. Yeah. Okay, so we've done this bit. We still have reset connection, and the reset connection, I just need to pass those 3 lines pretty much to get into that point, or I can go through my 5 volt. Now I could go inside and out, so if I really want to be tricky, what I could do is, let's just see if I can do something real tricky. Come from here, in between the pins. It's not it's not a graceful solution, but it worked. And that reset pin, I can connect to it from the side, and it's not going to go unbalanced because it's a large component. Now that connection is fine. You're going around those pins. Look, I don't like it. I would rather cross to the other side if I have to, and not deal with this. So I'll actually delete those segments, and I'm just showing you that you could do that, but yeah, we don't want to. So I'll delete that, and I'll probably delete those two as well and redo that differently. So to cross this, crossing 5 volt will be probably easier because you only have 1 track to cross. Not a huge deal. A ground plane, I don't want to really isolate it with another track if I don't have to. So yeah, what I'll do is I'll probably cross those 3 tracks. I'll move this one in. Okay, so we are close there. We've got a little space there which we can either eliminate, or we can put grounding pin through. I'll probably eliminate it since we don't have that space. We may as well eliminate that one as well. That's nice. And reset. I'll run this reset out here. V, cross to the other side. V, cross back up, and connect directly in. I'll just run it straight through. Oh, there's a ground plane there, sorry. What I'll do is I'll run it right into there. This way. Are we not doing anything? No. Yeah, we're not doing anything nasty. We're not dividing any sort of important ground planes through there, so that's a good connection. I'll save this. And that's it. So this area is done. Now there's another 2 lines which we need to cross and connect, and another 2 capacitors. So not much to do. Let's just see if we can cross this bunch of lines there. I'll come from here, and I'll just come as close as I can here. Press V, on to create a point there, come to the other side, and yeah, I don't need to do anything funky there. No, that's all good. V again, and I'll just run this like so initially. Now second one, I'll just run it to this point, press V again. I'll run them in parallel, doesn't really matter. V again, and I'll just see if I can trace it along, just tag along there and connect it there. Done. Now, you can see that everything is now connected. I'll just save this. Everything is now connected, and we've only used a few small bridges. We've got 3 lines there crossing to the other side of the board. We've got 1 here, 1 there, and another couple or 3 here. That is actually really good. In a lot of cases, you'll have more bridges, depending on the configuration. Obviously, that sometimes you really have to think very hardly not to cross. But this is ideal situation, because if I switch off I'll just turn on my 5 volts again. I'm still missing 5 volts there. When I switch off my top layer and switch off my components, which I don't think I can switch them off actually, but you can see that it's basically uninterrupted ground plane with a few little connections here and there. Not a big deal. Okay, I'll turn that one back on. Next, and now we still need to run power to the main chip. And this is where it gets a little bit tricky. So what I'll do is I'll connect those two capacitors, because there's nothing else happening there. I'm not going to use this area. So move this one close to this pin over here. We've got a ground pin there, which means we want some sort of spacing in between. So I'll just move this one down. There's ground here as well. So we don't have much choice, I guess. I'll move this one back up. Put this one here somewhere. And connect them, but using thinner connections. So I'm going to 0.25 for power. And just connect it through there. Now, doesn't want to connect directly this way, so I can just escape and go from here out there, and from here out here. Now, at the moment, that's okay. We just need to make sure that those ground planes have enough space there to come through. We can always push those two lines together. So, for example, I can move this one up like so, just to make sure that we've got slightly bigger space here. Okay, so that's done. So we still need to supply power. And in this case, I'll just zoom out, save. In this case, it's always sort of, what is the shortest path? You know, we've got the rail coming all around, which means that we could run this power from, bottom, top, side, or back, whichever way we want. But we really should try to minimize those power connections, the bridge, because we need to bridge it. We need to actually go under the board, run power on the other side of the board, and bring it into the chip. I like to bring power to the chip always inside of a chip. It's a bit unusual. A lot of people don't do that. Why I do this, because then I can distribute that power into all my power pins from the inside, and I've got space on the outside for my capacitors. You can also put capacitors on the back side of the board and put power from the top. I don't like to put capacitors on the back side of the board, simply because it increases cost of the board, and there's no reason to do that unless you are really forced to. If you really are struggling for space, you can do that, but otherwise, in this case, we've got heaps of space. We really don't have to worry about it. So what I'll do is I'll make sure that we've got enough space here, because you can see that there's a lot of space in this area, which we can utilize to create this jump. So what I'll do is I'll change those two lines. I'll actually move them a little bit. Probably want to create another. Okay. I can bring it across like this. This one, I can run it across like this. It comes in on angle, but that's fine. I mean, you can fix it if you want to, but those are big pins, so you can come on angle into it. And I'll do the same for this one. I don't even need to come this high. I can leave a little gap there. Okay, that opened up this area and made this path really short. So now I'll change this back to my net class width, select the track, and I can run it directly from here, from that pin, or I can run it from that rail there. It doesn't really matter, that's a thick connection through there. I'll just run it from that pin, and I'll say, okay, from here, I'm running my track right there. And what I can do is, actually, I'll come up a little bit, then run across V. I'll connect maybe from here. From here, I go inside of my chip, and I'll go like this. Doesn't really matter where you go, but I go like this. And I'll run it on angle like this, right to this point, put V in, via, click there. And now I run this back here and do V again and click there. So what I've done is I've actually joined those two V's together, and we've got two tracks. If I switch off my front, you can see that it's blue. If I turn it back on, you can see it's red. This is a trick which I use quite often. If I want to make sure that I've got lots of power coming through, I can run it on both sides of the board and stitch it multiple times. So now what I'll do is I'll get this V, select it, copy that, paste it again, and put it in the middle there. That makes a triple connection. So effectively now I've got 3 points where the power comes from under the chip, on the other side of the board, under the chip, on the chip side of the board. You can do the same here. So for example, if I move this track down a little bit so it aligns better, yeah, I can copy this via, so just select it, Control C, copy, Control V, and I can stitch it and stitch it, put a couple of stitches there. And now I need to join them together. So if I switch off my copper on the top, those are not connected, but I can just create a connection from here to there. Sorry, escape. I'll switch that back off. What I need to do is switch to the bottom layer. Okay, and now I can create my track. From this point, they're connected. So I've got 3 points of contact there, 3 points of contact there, coming through the board to the top layer, and the top layer, if I switch off the bottom, you can see that they are connected top and bottom. That's a really good connection, very solid connection. Now, if I want to, because that corner space, I will need that corner space. Actually, I've got plenty of space. I don't need to worry about it too much. So no, it should be okay. That's it. So now what I need to do is distribute that power internally here. So I'll go back to my switch on my top layer. Internal connections can be thinner, so I'll switch my track width to 0.25. And now I can connect 5 volts. I can put this 5 volts here or there, doesn't really matter where. Just put it here. This 5 volts and this 5 volts. So I've got a good distribution of 5 volts into our processor coming from the inside of the chip with capacitors on the outside of the chip. This is the configuration I like. It doesn't mean that you must do it this way. This is the way I do it. Okay, so I'll zoom out, save, and we've got all our tracks connected. So nothing is missing. Next step is going to be we'll run through design rules checker, but also we need to create ground planes. So I'll break this recording and then we'll go for the next next recording in a minute. So that's all good. I'll save it and stop recording.